If you like this video, make sure to visit our Vimeo page and follow us to get the latest update.
Today's session is, we're going to be talking about Introduction to HANA. It's a continuation of what we discussed last time. So as a quick recap as to what we talked about, if everybody remembers what we did, we talked about the evolution of SAP as a product and as a portfolio. Can anybody tell me, we talked about what was this ERP system, Enterprise Resource Planning, and we said in 1972, 5 IBM employees combined together and started this company called SAP. What was the first product that SAP created? Can anybody on the chat window type in the answer for me? What was the first product called as? Just as a quick recap, let's not spend more than a minute on this. Perfect. So the first product that was brought out by SAP company was, if you remember, SAP R1, right? R1 stands for, R stands for real-time integration, and 1 refers to one-tier architecture. And does anybody remember what was that one tier in which SAP was installed? We are talking about 1970s time frame. So what could have been that? Perfect. Cool. Thanks, Kofi. So the one main, it was built, it was installed on top of a mainframe system, and that's how the systems were created. Then we know that we went on to R2, 2 being the two-tier architecture, application and database, both sitting within one server. And then we went into R3 as a product. The 3-tier architecture here stands for a client, application server, and database server, all living independently of each other. So we looked at all this information, and then we went through the evolution. Hope everybody remembers. We went through 3 different periods. I'm not going to talk about each one of them individually. If I were to broadly categorize them, we started off with SAP ERP as the idea in the 1970s to 1980s. We understood what were the goal and what were the challenges. Day-to-day operational reporting was key. No advanced reporting. That was the issue. We moved on to the next generation, which is 1990s to early 2000. We called it as the globalization era. SAP came up with 16 different complementing solutions. One of the key product that came, if you were to identify one key product that came out in the 1990s to 2000, can anybody tell me what was the biggest challenge in the previous era? And in order to solve that, what was the key object that was created during the 1990s to 2000 time frame? Anybody? Perfect. SAP BW, right? Business Warehouse was created so that it could help directly answer this question of advanced reporting. We understood what were the opportunities because it was now able to provide reporting, advanced reporting. But what was the challenges? I think Mike already answered the next question. Perfect. Thanks, Mike. The challenges that we faced is we did not have a good reporting tool. It's very critical that we not only have the capability, but we should be able to present that information in a nice manner, right? The rendition is also very important. So in the next generation, which is from the 2000 going forward, one of the key things that SAP did was they went and purchased a company called Business Objects to get a set of reporting tools. We looked at that, and we also saw that the subsequent invention or new products that were brought into the market, one of the key things is SAP HANA. And we looked at the reasoning as to why we maybe at the surface level, we touched upon why we brought SAP, why SAP company brought this new product called SAP HANA. We said that at that point, SAP did not have its own database. This was the reasoning I had provided to you in the last session, but that's not the entire truth. I was slowly bringing into the concept of why SAP HANA came into the product portfolio within SAP. But there is a little more information that needs to be provided to you to be completely understanding why SAP HANA came into the market. Is everybody good with the information so far? By a quick yes or no, please, so that we can move on to today's session. Perfect. Thank you. So that being said, today what we are going to focus on is we are going to try and answer a little more in depth the question of why. Why SAP HANA? We touched upon the surface and said that SAP did not have a database of its own. So it came up with a product called as SAP HANA. Did that happen overnight? Did they just go to sleep and the next day morning they came up with a product SAP HANA as a database? No, there is a little bit of background behind it. Let's try to answer that question of why and what today. If time permits, we will go into the next level of detail, which is the how question. All right. So let's take the traditional SAP product. What is our traditional SAP product? We know that there is an SAP software. The software can be SAP ERP. Let's assume. The initial problem was that it was being supported by a traditional database, like let's say Oracle or SQL Server. This is how a traditional system looked like. So what was the intention of an ERP system? Let's take a simple example just for us to understand what's going on. If I go to a Walmart, or if I go to a Kroger, or if I go to any grocery store, what you do, you go and purchase an item, and you will see that there is a person sitting in front of a computer or a register, or it's called the point of sale system. You go and make the transaction with them. You say that I am buying 2 shirts and 1 trouser and so on and so forth. And they enter that information onto this point of sale computer. All we are doing is you are establishing a transaction. When you establish a transaction, when there is a transaction between the company Walmart and the customer, that information about what the customer is, it will essentially look something like this. Customer, let's say customer name is ABC. Product, it will say shirt. Quantity, 2. Price, let's say $20 or whatever it is, right? This is the kind of information that is being captured when there is a transaction happening between a customer and the company. So this information, this record about that transaction needs to be passed on to the database. There are small tables sitting here inside this database, and that information is getting stored inside this particular individual tables. So if you look at the transactional system, the name of this transactional system is also called OLTP. OLTP stands for Online Transaction Processing System. OLTP, Online Transactional Processing System. So what is the key intention of an OLTP system is, anytime a transaction is hitting the system, its primary job is to take that data and store it in respective tables. So the key function of an OLTP system is to store transaction. Or in a little bit technological term, if I have to say, whatever transaction is getting brought over here, that needs to be written into a table. Is everybody with me so far? Is it making sense? The intention is, if I go and purchase something in Walmart and I make a transaction, the primary function of that particular system is to take that data and push it into a table within the underlying database. The underlying database could be supported by an Oracle system, or it could be by some kind of a database. the primary focus has always been on how to efficiently store the captured transaction in the underlying database. But as and when data got stored in this particular database, users, let's assume that I am a user sitting in the headquarters of Walmart and I'm one of the business users. I am interested in knowing what kind of sale happened today. How do I get to know that information? This user now will ask for a report. He or she will say, build a report for me, which will go look at one or many of these tables individually and fetch me the data. Now, if you all understand from our previous discussion, a traditional database, it is driven by mechanical device, as I explained it last time. So there is a physical limitation for how fast a mechanical device can process, right? Everybody hopefully understands that concept. So now I'm saying that there is X amount of power in this particular system. Out of this X amount, I want to spend most of it for efficiently storing the data, that is writing the information. If you were to prioritize this database's functionality, the first priority will be every time some transaction comes into the system, I have to take that transaction and place it effectively inside in the underlying table. That is the primary goal of a OLTP system. Now, all of a sudden, because this information is available within this database, users are asking for report information, which means now they are asking the system to perform read ability. I want to not only write it on this side, I am now asking the system to read the information and present it to me for reporting. So can you see that there is going to be a contention? I have limited power as the database. Now I'm torn between writing the transactions into the table, and at the same time, users are demanding that I want to read that information, extract that information from that table, and be able to present it for reporting cases. So when this happened, they found out that there is a lot of contention or resource constraint or bandwidth issue. Given I have so much amount of processing power, I'm torn between writing and reading. This is not a good practice. An OLTP is primary goal is to be able to write the data efficiently, so that because I cannot lose track of any transaction that's happening in the organization. So in order to solve this problem, what SAP did was they said, let's bring another database. Let this database be either an Oracle or a SQL Server again. Let's copy over all the data. So essentially, copy data from SAP ERP to the system. So all the tables data will come and reside in this particular system. Now what they did, they created another application on top of the system and they called it SAP BW. So what happened? On a nightly basis, data from here moves and gets copied over into this particular system. Now, the intention of this particular system is, they said, let's cut out this user request. Let's move this read ability to this particular system. Now, users, the same users can run the report. This report will now be connected to this database. The database that is being supported by this application called SAP BW. And you can go and run all the reports you want without causing any resource constraint on the OLTP system. So this system, this is an analytical system. So this BW system is coined as OLAP system. OLAP stands for Online and Analytical Processing System. Online Analytical Processing System. All right. So now they solve the problem of running reports moving from this particular system to this particular system. So the challenges Can anybody tell me in this particular approach, what is the biggest drawback or negative in this entire process that we just talked about? Can anyone tell me what is the biggest issue that I'm going to exactly? Virendra is absolutely right. I am unnecessarily duplicating data. Can everybody see that? If there was, let's assume there was 1 terabyte of data here, I'm moving that 1 terabyte of data again into this particular system. See, speed in a way, it is now becoming better, right, Lokesh? If you look at it, if a report was run on this OLTP system, where that OLTP system is trying to fight between storing the transaction and retrieving the transaction for your reporting, the speed is going to be slower. But now that the data has moved into this BW system, that BW system is not capturing transaction. It is only meant for reading the data for reporting functionality. So what's happening? The speed has improved. But in order to make this facility available for your users, you have compromised on duplicating the data on a daily, on a nightly basis. I have to push whatever data came to my or to my OLTP system. I have to keep pushing it into the BW system. So the negative is I am duplicating the data. The advantage is now I have better reporting. Would everybody agree? So one problem solved. I'm able to provide better reporting without causing any resource contention on my OLTP system. But on the contrary, I am compromising on another system holding duplicate amount of data, which means that I have to constantly maintain it, right? Every night I have to start pushing data from the OLTP system onto my OLAP system. But this kept growing. The BW system became the go-to reporting system for everybody in the organization. So what happened? Naturally, as and when you keep pushing data into the system, what's going to happen to the volume of data that gets stored? Naturally, the volume of data that gets stored in the BW system is going to increase significantly, right? Today, you have 1 day's data. As years goes by, the BW system keeps track of all your historical data. So now you are having multi-year data worth of data sitting in this system. So the volume kept increasing. When the volume gets increased, let's say I had 1 million record initially, but now I have like billions of records. I have billions of records to be processed for reporting. What's going to happen to my reporting performance when I continue to hit the system? The reporting performance is going to take a hit. Would everybody agree? With the increase in the volume of data in the historical SAP BW system, the warehousing system, the performance of the system is going to come down. So some of the things that a traditional SAP BW world did was they said, okay, I will look at this particular table. If this particular table contains, let's say, 2015, 2016, 2017, 2018, and 2019, let's assume that 5 years of data is still sitting in this particular table. And looks like the users, when they run a report on a daily basis, they're currently only looking at 2019 data. So they came up with some technologies within the database like indexing, partitioning. To help, they tried to partition this table into, let's assume that 5 different tables. One table containing 2019 data, one table containing 2018 data, so on and so forth. So what happened? They tried to lessen the pain caused by the increase in volume. And they said that instead of one table, I have split it into 5 different tables now. Knowing that the user is commonly asking for 2019 data, I will push them to the 2019 table and they can retrieve the data relatively faster instead of going through all the 5 years worth of data. But you can only do so much of partitioning and indexing, right? To make one thing better, you're now adding a lot more maintenance in your system. So in order to solve this problem, SAP, what they did is they kept constantly looking at what kind of products can I come up in the market or look at examples that is happening in the market and see how I can improve this performance. So this was not just an SAP problem, right? This was an across the industry, IT industry problem, that with the volume increasing, how do I not compromise my reporting for performance? So SAP, with the help of few PhD doctorate students, they went and looked at several products. And one of the things that came back very promising is if you look at the Google engine, Google search engine. If you can all imagine, when you type a question in your google.com and you hit enter, you get millions and millions of records instantaneously. How is it able to bring back that information? There is some kind of an algorithm or an engine that's running behind, a proprietary algorithm that's running behind the Google search capability. So they started understanding what is happening in those scenes, and they created a new product called Trex Engine. They came up with the SAP company came up with a product along with these PhD students. They came up with a product called as Trex Engine. And that Trex engine was converted into a product called as BWA. Or let me change this color. And I will say they came up with a product called BWA. BWA stands for accelerator. Think of it as a power boost to your system. So this Trex engine is completely in memory. If everybody remembers the discussion we had last time, I explained how a computer works. The first time you query a computer, it goes into the underlying hard disk and tries to process the information. But after the information has been processed, it will come and put it on top of your RAM. And the next time when you ask for the same information, rather than going to the hard disk, it now goes to the RAM, which is your in-memory, and the retrieval of information is much quicker. Hope everybody remembers that. So using that same technology, this BWA is completely, imagine that it is sitting in RAM. They brought this BWA system and they established a connection between your BW's underlying database and this accelerator too. Now what happened? In order to solve the problem of high volume causing a performance issue for reporting, they started sending data from here to this particular system. Because this is now all in memory, when a report is run, it now knows whether I should go to this system and pull the data, or should I go directly to the memory rather than going to the hard disk. Should I go to the memory and fetch the information? So naturally, what's going to happen when the report is going to the BW accelerator, it's going to start performing better. If you look at the analogy that I gave you exactly for the computer, that's exactly same thing. Think of this particular as your hard disk and this becoming your RAM. Now the report has a choice to either go to your hard disk or to your RAM. Now what could be the limitation here? The problem, the advantage is now I have solved the problem of reporting performance, because no matter how much the volume increases, as long as it's staying in RAM or in memory, I'm able to reach that data much faster. So I'm not compromising on my reporting performance. But just like you guys, everybody mentioned a few minutes ago, I'm still duplicating data. Would everybody agree? I'm still duplicating data. I have now added more maintenance to the process. I'm not only sending data from the traditional OLTP system to the OLAP system on a daily basis. I am now sending one more set of duplication of data into my BWA system. Now looking at this, if you look at it, do you think that this is a sustainable option? As the data keeps growing, if I continue to be churning and duplicating the data from one system to the other, it doesn't seem like maybe 10 years, 12 years, 15 years ago, the amount of data we are talking about could be probably in high gigabytes or maybe touching terabytes. They probably go to 1 terabyte, maybe 2 terabytes. That was the maximum amount of volume increase organizations were seeing, even big organizations. But if you look at the last maybe 10 years or so, the volume has significantly increased. Now companies are talking constantly in terabytes, even going into exabytes and petabytes. That's the kind of exponential growth that we are seeing with data. So if you take that thought process into your mind, can you tell me if this process, sending the data from your OLTP system to OLAP system and OLAP system into your BWA, is going to be a sustainable option? No, right? Because too much of work is happening, and it's definitely not going to be keeping up. And I'm doing a lot of maintenance work in addition to that. So SAP said, I really like this concept. We came up with a very nice concept called as in-memory accelerator, supported by this Trex Engine. But by keeping it as a sidekick to my SAP BW system, I'm not gaining much out of it. They started looking at this product individually and said, what if we make this itself as a database? What if we can avoid an intermediate database and rather go use the BWA itself as a database? And that is how SAP HANA. So SAP HANA product was born out of this BW accelerator concept. Does that make sense for everybody? By a quick show of yes or no, please. This is very critical to understand, because this now goes into details of why SAP HANA came into the market. Excellent. All right. So if you look at it, now we are talking about, we understand the why. BWA was a big issue, and in order to solve that problem, so now I'm solving two problems with one product. I could have not sustained the continuous growth of volume by using a BWA, because I'm going to duplicate the data. I'm going to maintain 3 different systems: OLTP system, OLAP system, and my in-memory BWA system. It's not going to be a sustainable approach. So that is the reason why SAP came up with a newer product called as SAP HANA. But when SAP HANA came into the market, as you all can now understand, because it came from that BWA concept, it was a pure database in nature. All it did was, it took the concept of this BWA. What is the proprietary concept of this BWA? The Trex Engine. It took that concept and it became a completely in-memory database. But for a database to be called database is just, so what was this in-memory system capable of, the BWA? It was good for supporting my reporting. Or if I were to call it technically, it was good for read capability. For a database to be functioning as a database, can it just be able to do read capability? Would that be sufficient for a database to be called database? Or should the database also have the capacity to write information into itself? Just like the concept of OLTP, if you remember, the functionality of the underlying database of an OLTP system was to efficiently capture the transactions that are coming in and appropriately place them in different tables within the system. So wouldn't you think that a database has 2 critical roles? One, it should be able to write the data into individual tables, and at the same time should be able to read the data from these tables to help you with reporting. So read and write capabilities are very critical. So if you look at it, SAP HANA just being an in-memory database does not make it an authentic traditional database and can be compared with other systems like SQL Server and Oracle. So SAP also understood that just having copied that Trex Engine capability into SAP HANA does not make it a well-rounded database. So what SAP did was, in addition to borrowing the technology from the Trex engine, they added two other technologies. So essentially three different technologies were married together to make this product called as SAP HANA. So now we are talking about what are the technologies, the question of what technologies came together to help make this database, SAP HANA database, a well-rounded database. So let's understand what are the three components. We all understand the first component is your Trex engine. Trex engine brings that in-memory capability. How to efficiently read information from your system. Trex stands for text retrieval. Just a second. Text retrieval and extraction. TREX. Trex engine stands for text retrieval and extraction algorithm, and that algorithm is mainly focused on giving the read ability to your SAP HANA. Now let's take the comparison of a SQL Server or an Oracle. If you remember, that correct naming terminology for these databases are called RDBMS, Relational Database Management System. For a database to be able to be called RDBMS or a traditional database, it should have the write capability. Just the read capability alone is not efficient. How do I get a transaction and how do I push it into a table in a correct format? Now at this point, SAP HANA only has this Trex engine capability, right? So what is lagging is, in order to make this SAP HANA a true RDBMS, to be able to compete with other RDBMS in the world, what was lagging behind is the write capability. Now, in order to get the write capability, there are so many other databases that are available in the market. So SAP, instead of starting everything from scratch, what they could do is they could probably have gone to one of these companies, acquired them, and took the technology of an RDBMS and plugged it into this HANA database to make it wholesome. But what happens is, imagine, you know that you have a Ferrari and you know that it's going to run really, really fast because of its Trex engine capability. But just because you need a steering wheel to drive this car, you don't want to put a heavy steering wheel inside your car, because in order to keep your Ferrari fast and sleek, you want to keep the artifacts or the objects inside that car to be extremely sleek and lightweight. You don't want to overload it with heavy objects, then defeating the purpose of having that performance, right? So what SAP was cognizant about is, they said, I want to go and look for a company which has a database which is truly RDBMS in nature, but I don't want a heavyweight database. It's like they could have chosen to go to a SQL Server or an Oracle and probably struck a deal with them and said, I'm going to buy your company and I'm going to bring your SQL Server database or your Oracle database capability into this HANA. Then what is going to happen? I'm going to slow down the capability of this in-memory system by overloading it with a heavy relational database management system. So that was not going to happen. So as they were looking at different products, they came up with an online company called Pstartime. A Pstartime is an extremely lightweight relational database that gives you that apt information of how to efficiently write information into the system. So this brings the write capability of the RDBMS. So they said, they looked at this particular system, they said it has all the write capabilities, but it doesn't come with a heavy burden. So they went and acquired this company called Pstartime, and this supports that write capability of the SAP HANA system. Now I have taken care of my read capability. I have taken care of my write capability. But can anybody think of, I said there are 3 different technologies that came into, they were brought in, blended together to make this final product called SAP HANA. Can anybody tell me what is missing? Just looking at this particular system, what potentially is missing that is going to be solved by a third piece of technology? Can anybody think about what happens? Let's see if there is an answer. So Fred is saying reporting. See, I can now answer reporting with this particular capability. Would you agree, Fred? Because I have the Trex Engine part of SAP HANA, it helps me with reading, which is nothing but reporting. So it is capable of now reporting the information that is already stored in the SAP HANA system. Somebody is saying parallel processing. The Trex Engine will provide that parallel processing capability. I will talk about it right away in a few minutes, Aditya, so you will understand what we are talking about. So Kofi is saying storing data. Storing data is now capable because of the Pstartime, Kofi. That gives you the ability to store the data, write the data into the database. So storing and reporting is perfect. Fred, I think, got the answer. Fred is saying backup. Now let's think about it logically, right? If you take your pen drive or your flash drive, which is in memory, which is a RAM kind of situation, what happens if it gets corrupted? Let's say a lightning struck when you were using your flash drive, or something happened. What happens to let's assume that the flash drive had 1 terabyte of data stored in it. What happens to that particular RAM object or the in-memory object? It gets fried, right? The data gets completely lost. So imagine now I have a very powerful system called SAP HANA. The entire data of the system, 2 terabytes or 10 terabytes of data, is all now sitting inside this in-memory tool. What if a natural disaster happens or a power outage happens or something goes wrong and my database is shut down? Everything is volatile. Anything that sits inside a memory is volatile in nature. So when I reboot the system, all the data inside the system is gone. Do you think that any organization would buy this product if I say that, okay, as long as your company is capable of keeping it running all the time, you're safe. If at the time when there is a power outage, your data is all completely wiped out. That's not an acceptable scenario, right? So the third piece of technology that is critical to this particular database is, how can I back up this information? Everything that is sitting in the memory needs to be backed up only for situations where there is a power outage or some kind of a disaster happens to the system. When I reboot the system, I should be able to bring back this backed up data back into my in-memory. So SAP had explored creating a database long time back. They had created a product which was not successful, which is a traditional database. When I say traditional database, they created a product called SAP MaxDB. This is a traditional database. Why I call that a traditional database is it is driven by a mechanical device. Data is stored in a mechanical device, just like your SQL Server and your Oracle. Unlike your SAP HANA, there is nothing concept as called as in-memory. It's a true database where information is stored. So what they did is, we already have a technology called MaxDB. Let's bring that MaxDB here with the sole purpose of backing up my data. Now what happens is, every time a transaction, an entry comes into this system, into my SAP HANA, the data is stored in the in-memory capability. So everything is now stored in the in-memory. But consistently, that data is copied over into MaxDB. Now, immediately, some of you will ask me, if you are going to copy over all the data that is sitting in your memory directly in your MaxDB, aren't you doing anything? You're simply doing the same thing that used to happen in the BW. You are duplicating your data from here to here. Did anybody think of that as a possible question? In the previous time also, I was duplicating data. Here also, even though I've come into an in-memory technology, I'm still copying the data over into this technology called MaxDB. To help you answer that question is, unlike the BW system, where the duplication of data was used, whether it was in OLTP system or in your OLAP system, the data here was used for some purpose, the data here was used for some purposes. So they were actively being used, whether it was sitting in your BW, whether it was sitting in your BWA, both the data were being actively used by some reporting. But in this case, the only intention of this MaxDB is to remember that the system is volatile and I need a backup. This only gives you the backup capability. Nobody can read or run report on top of this third technology. So this third technology is not accessible for anybody. Every time a data gets written into an in-memory, it automatically gets a copy of it sent to this backup only for true backup capability. It cannot be leveraged for any reporting, or a user cannot decide to write a transaction directly into the MaxDB. For the outside world, MaxDB capability is completely cut off. They cannot understand, they cannot touch it, they cannot retrieve information from it. It is exclusively kept for the volatile nature of the in-memory system. If power outages happen, immediately when the system gets turned back on, the copy of data from the backup MaxDB goes back into the memory. That is all it can do. There is nothing else you can do with this backup capability. So now SAP HANA, by bringing in these three technologies together, they have answered the reporting performance capability using the Trex Engine. They have answered the traditional write capability using Pstartime. And knowing that it is a volatile system, brought in the backup capability to help solve that issue of volatility also. Does that make sense for everybody? So these are the three different technologies that come together and make SAP HANA as a powerful system. A quick show of yes or no, please let me know if you can understand the information. It's critical to know this because anybody who's a layman who's just heard about HANA can talk about high-level stuff, right? They can say, oh, I know SAP HANA is an in-memory system. But when you go out right after this and join a project, you are going as a HANA consultant. You are expected to know what are the underlying technologies that are helping me make this SAP HANA database a powerful system. Now, we understand that the Pstartime is capable of doing all my write capabilities. How to efficiently push the data into a table, how to split the data and send it into multiple tables, and so on and so forth. We are understanding that. But if you look at this particular case, the Trex Engine, this is still looking like a black box to me. Would everybody agree? I don't know what is going on inside this Trex Engine, but I understand it is helping me with faster read and reporting performances. But as a HANA consultant, as I said, you need to know more about what's going on inside the hood so that you appreciate and you can command. You can, when you talk to somebody, when you talk to, let's say, for example, you go into a project and the project is at early stages. You will be meeting with a senior management. And when you talk about it, you can explain. They probably would not know what SAP HANA database is made of. So you can showcase, you can shine there by giving them some additional information on what is actually happening within the system. So now we are going from this, we understood what the technologies are. We will go into how each of these technology is working. This Trex engine provides multiple capabilities. There are certain things that are happening within the Trex engine that's actually making your system even more powerful. If I were to broadly categorize them, the advantages or what is going on inside my Trex engine is there are three broader categories of information. One is there is a traditional shift from row versus column storage. And I will explain. If you don't understand what it is, don't worry. I will explain it to you from scratch. You will understand it. Then somebody mentioned about parallel processing. I believe Aditya mentioned about parallel processing. We are not just talking about parallel processing. We are talking about massive parallel processing happening within the Trex engine. In short, it's called MPP. And finally, something called as a push down mechanism. These three broader categories of information is what is making your Trex engine so powerful. So we will go into each one of this and understand what these capabilities are. And then you will be able to appreciate and now say that, okay, I know in depth how this in-memory tool is working. What are the differences from a traditional database to this HANA database? All right. So let's take the first concept, row versus column storage. If you take a traditional database, let's say SQL Server or Oracle, whatever may be the case, we're saying that data, when the data comes into the database into an individual table, we have a high level information of how the data gets stored, right? Let's say I have a table which contains customer information. There is a customer table. This table contains customer ID, customer name, let's assume customer age, customer address, and customer phone number, so on and so forth. I'm just giving you an example. Let's give it a number 1, maybe Tom, 25, ABC, and then phone number is 1234. Let's assume this is how a data would look like if you were looking at a table. Wouldn't you agree that this is how some information will be stored? Each column contains an associated row. This is the data. So let's take a simple example. In the same database, let's assume that there is a sales table. There is, let's say, year, country, product, and let's say there is an amount. Just assume that there is a table in this traditional database where you have a table called sales table, and it contains basically this 4 information. Let's say 2021, country United States. Let's call product as A and amount is $100. There is another product in let's say United States, and then I have product B 200, and let's say let's assume that I have a table like this which contains year, country, product, and amount information. Now, to explain what a row versus column information is, you need to understand how data gets stored in a traditional data storage in a traditional database like SQL Server or Oracle happens. You need to understand how when the data is pushed into your database, how does it go sit inside the database? In a traditional world, what happens is data is stored in tuples, and I'll explain what it means. Imagine there is a continuous memory. Has anybody, I'm sure many of you would have, when you go into your laptop or your computer, the system will ask you to do a functionality called disk defragmentation. I'm sure many of you are familiar. Can anybody give me a quick yes or no if you're familiar with this concept? So what happens is over a period of time, when you keep storing information in your computer, the information gets stored in multiple different places, creating a lot of holes in the system. When you do a disk defragmentation, what it will do is let's assume that it put a file A here. Imagine that this is your memory, okay? This is your entire memory in your computer. You stored a file and the file A got stored here. And then you put another file later and that file got stored, let's assume file B here and file C here. Now, there is a huge hole in your memory. This is how traditionally any computer is going to store your information. It is not going to store file B right next to file A and file C right next to file B. It's not going to do that. It will individually place it in some place within your memory. When you do the disk defragmentation, it will go check all these empty spaces. And then what it will do is it will remove this empty space and align. It will bring your file B next to file A, bring your file C next to file B. So bringing together all the files and storing them one next to other, so that at the end of this disk defragmentation, what your memory would look like is it will say file A, file B, file C, and then whatever free space is available, that is available to you. So basically it's a cleanup act done by your system. Now the reason I talk about that is, now let's take this concept. Imagine that your database has this memory and you are now asking it to store the data from this sales table. I'm pushing this data into this underlying database. Let's assume how the system would go about saving it in the traditional database. So think of it as memory chunks. Okay, there are memory chunks that are available in the system in your database. In a traditional database, it will start from row 1. It will take the value for year. So it will plug it in the first memory chunk. Then it will move on. It will take the next value US, move on to the next A, move on to this one and 100. It has completed the first row. It will move on to the second row. 2021 US B 200, 2021 India C and 50. Can everybody understand what I'm doing here? It is, think of this as contiguous memory or continuous memory. Memory chunks that are inside your database. In a traditional system database, it will take each value and place it in its own memory chunk as it goes through every record. Does it, by a quick show of yes or no, can you understand what we have done so far? In a traditional Oracle or SQL database, it takes your data from the table, and this is how the memory is storing it. Now, by storing it, so there is, Mike is saying no. So imagine that you have a big suitcase, Mike. I am giving you 10 different objects to store inside that suitcase. So a traditional database, what it will do is it will take the first object, place it in the first position within the suitcase. Take the second object, place it right next to it. So it will take contiguous space. You will arrange it, objects, take one at a time as it is arranged outside. You take it and you place it within the suitcase, one after the other. That is exactly what a traditional database is doing. It will store information read from the table. When it is stored in the memory, this is how it will store it. It will go sequentially, read one record after the other and place it inside your memory. Now I'm talking about behind the scenes, how the table stores its data in the memory. Okay. Mike has a question. What happens when data is deleted? We'll get to that in a minute, right, Mike? Let me first explain as to, so if a data gets deleted, there will be a void, just like your defragmentation. That particular section will become empty. It will not be reused until a cleanup happens. Okay, this is how a traditional database is going to store every record. So if there are 1 million records, it will continue to go. Imagine that there is this never ending memory chunk and it will keep pushing your data in this format. Now, this is called, if you see, how is it reading the data? It's going row by row. Would you everybody agree? This is called row storage. In a traditional database, the data from the table is read row by row and it is put into memory chunks in a contiguous fashion. Now you might ask me, okay, what is so big about this, or what is so fancy about knowing this way memory is allocated, right? I'll explain it to you so that you will understand it. Now, I am a user. I want to run a report on this table and I have some questions. My first question is, tell me total amount generated by this company. I have a simple query. I want to know what was the total amount generated by this company. By quickly looking at this table, a layman would say, how much is the total amount I have generated so far? Can anybody give me a quick answer? Looking at this table, can you tell me what is the total amount the company has made? 100 plus 200 plus 50 makes it 350. For a layman, it's very quick for me just to look at it and say, this is amount is 350, right? But let's look at how a traditional database calculates this. It will first, in your memory chunk, it will go through the first value, 2021. It will say, does it make sense for me to know what 2021 stands for? No. It will move on to the next field. US, is it a value that I need to be considering? No. It will move on to the field called product. It will now say, okay, does it matter what the product is? For the question that is asked, I want to know the total amount generated by the company. The year, the country, the product did not matter to me. But what is happening? Because the data is stored in a row format, the system will anyway process that information. Even though there is no value add to looking at 2021 or US or A as a value, it will still process that. And then it will go to this amount field called as 100. It will say, I think this looks like a information that I need to contain. So it will retain that information called 100. It will move on to the next row, 2021. It doesn't matter. US doesn't matter. B doesn't matter. It will come to the value called 200. It will say, okay, now I need to capture that information also. And then it will continue to do the same thing until it goes to the last one. Then it will calculate the value as 350. Is it helping understand why I'm going through this exercise? To show you how inefficient it is to store the data in the way that is presented now. If I wanted to get a summarized information, I'm interested in knowing what was the total amount generated by the company. All I needed to know was the amount information. But because I have stored the information in a row format, it had to go through every value and capture that information, no matter whether it has relevance or not, to find this answer called as 350. Let's assume that this probably took me 5 seconds to process the information. Is everybody with me so far? Next question. Let's assume that I want to know which product. Let's keep it simple, right? So now that I've expressed a question, and to answer that question, I had to go through all the 3 records to figure out what the answer was. It took me some time. This is how the data is stored in a traditional SQL Server or Oracle database. Now let's take the same example and understand how data is stored in a HANA database. Why HANA database is different. If you take the same information, what it will do is the memory again memory chunk, but you will see that the memory is stored in a different way. Instead of going row by row and figuring out the information, when a HANA is presented with data in a table, how it will store the information is it will go column by column. It will go look at the first column called year, and if the year value is repeating multiple times, 2021 is repeating multiple times, and there is 2020 repeating multiple times, and so on and so forth, it won't store all the values, all the repetition. It will look at your column and it will identify the unique entries that are available in this column called year. It will say in this particular table, there is only 2021, and it will store one time 2021. Then it will go to the next field called country, and it will figure out US repeats twice, and there is value for India. It will go to the next value called product, A, B, C, because there is nothing common about them. So they're all individual values. And then it will store the data as 100, 250. Now, when you look at it from this memory chunk, you will say that I don't understand how the data is going to be, how this value is connected to this and how is this connected. That is the Trex algorithm that they won't reveal to us, right? Just like Google will not reveal what is the algorithm they have to have that interlink between the values, that they won't say. But imagine this is how the data is stored in your SAP HANA system. Try answering the same question with this. In this case, the system is, because it is storing data in a column fashion, what it will know? It will know that column year, column country, and column product are not necessary for me to calculate. It will directly read the column called as amount. The answer is 350. Because the data is stored now like this, it will have data is stored. There is a year, there is a country, there is a product, and there is a amount. Year, it will store only one value for year because there is no repetition, there is no new unique values. Here, US repeats twice, and there is India. There is product A, product B, and product C, 100, 250. This is how the memory would be storing in a column format. To answer your question about how much was the total amount generated, it will directly hit this column and say the answer is 350. This will probably take a second to fetch the information. So at a high level, can you see the difference in storing the data in a row format versus a column format? By a quick show of yes or no, can you let me know? Are you seeing the differences? A traditional row format, you have to process the information, even the unnecessary information, to get to the answer. But in a column format, you can directly hit a specific column and get your information. So just to elaborate on this a little more, when the question or the query that you have is summarized in nature, when I say the data, the type of the query that you're asking is asking for a summary type of question. Let me go back to the table here. If I say, if I had this particular table, let me repeat this table here so that I can explain the concept. So you have year, country, product, and amount. 2021, country US A 100, 2021 US B, year, product, year, country, product, and amount. 2021 US A 100, 2021 US B 200. Let's say there is 2020 India C50. I'm just giving you a variation of what we have. Let's assume that this is the table we have in the system. When I'm asking what is the total amount generated, it is summary in nature. Would everybody agree? I'm not interested in knowing individual records value. I'm just interested in knowing a summarized information. Let's assume that there was another field called quantity, 20, 30, and 40. So tell me what was the total quantity ordered. Would everybody agree this is also a summary question? This is perfect, right? So the answer is 90, but what we are asking for is, this again is a summary nature. In order to know that the value is 90, is there any relevance in knowing which year it came from, or which country it came from, or which product gave me that value? No, right? I'm not interested in any of those details. I'm just looking at overall high number. Tell me what is the total quantity generated. Whenever your question is summarized in nature, it is, you will see that storing the data in a column format helps me retrieve the information much faster. Again, if I were to ask you a question, which country generated the most amount? Is that a summary question? I only need to look at 2 columns out of these 4 columns, 5 columns, right? In order to answer this question, which country generated the most revenue? In order to answer this question, I need to know the column called country. It is in a way still summarized, Vijayata, and I'm quickly explaining that, right? Because if you look at it, I did not want to know which year it belonged to or which product it belonged to, or I'm not interested in knowing the quantity. All I'm interested in knowing is of this detailed table. If I go to these 2 columns alone, I can answer your question, right? So it is still summarized in nature. I don't need all the details of the table to answer my question. That's where I'm heading to, right? So as long as the questions are summarized in nature, and if you look at your analytical reporting, right, invariably your analytical reporting is going to always start with summarized question. Tell me what was the sales for this quarter. Tell me what was the sales for this summer. You always start at a very, very high level information. And if you want further details, that is when you will go from a high level information to the details, right? That's how analytical reports always work. So imagine now for me to run the report, would you choose to store it in a row format traditional database, or would you choose to store it in a column storage to retrieve faster detail when the question is summarized in nature? The choice seems very obvious, right? If I go to a HANA database which stores the data traditionally in a column format, data retrieval is much faster in the column format. But you might even ask me the same if I were to probe this question a little more. But there are cases where people will ask me detailed question. Now I want to know, tell me everything about the transaction that happened in India. Now I want to know everything about the transaction that happened in India. Exactly. Vijayata is absolutely right. So when your question is summarized in nature, columnar storage beats row storage any day. It's extremely powerful when it is, because you can understand, right? Because it can directly go to the necessary columns only and fetch the information rather than processing every unnecessary record that is stored in the system. It can directly go to necessary columns and fetch the data. But now, on the contrary, if I had a detailed question, I need to know everything about the purchase transaction that happened for country US. I need the information about the year. I need the information about the country. I need the information about the product. I need the information about my amount and my quantity. I need value from every column. If I'm going to read the entire row, storing it in a row format might be better suited. The reason is, it goes to this table in a row format. It will say, it will check if the country is India. No, right? It will skip this record. It's not going to process this information unnecessarily. Is the country India? No, it won't process this. Is the country India? Yes. So it will go row by value, and it will fetch this information. In this case, let's say it brings back the data in 3 seconds. I'm just giving you a hypothetical number, right? Just for you to put things in perspective. If the same question were to be answered by your column storage, there is no direct advantage of exploring the column format, because in this case, you have to anyway read all the individual columns. You have to go to this year column and fetch the corresponding value 2020. You have to go to the country and fetch the value for India. You have to go to product, fetch C, fetch 50 and 40. Because now everything is individually columnized, maybe it will come back in 4 seconds. So when the question is detailed in nature, even though you can get the answer from column format, in this particular case, row format might have a slight advantage over column format. But just because you want to get detailed question, you cannot go to a traditional database, right? So you can, you can say, anytime you want to fetch reporting data, whether it is summarized in nature or it is detailed in nature, you can blindly go to your column format, which is your HANA system. For detail, there might be a performance difference of 1 microsecond or maybe 2 microsecond, which for a layman, you will not see the difference. But there is a slight delay in the column format if you're going to fetch the detailed data. But the benefit you get when you retrieve summarized information is exponentially higher. What would take probably 10 seconds in a row format would bring that data in like 1 second. Vijayata has a question. Any real-time example where we choose row over column? Yes. So the real-time example itself is the summarized information, right? Anytime a query is run, always 99.99% of the time, the query is retrieved at a summary level. The initial retrieval of information from a database is always a summarized information. So the time taken for the initial response of any reporting is going to be supported by your column format, anything that is run within HANA system. So it is extremely powerful. So for you might, in your HANA database, when you create a table, and I will show it to you in the next sessions, when you create a table, the system will ask you for a question. It will ask you, do you want to create your table as a row format table, or you want to create it as a column format table? It will ask you for this choice. Now you might ask me, how do I differentiate? When will I choose a row format table for in HANA or a column format? If I chose a row format, I'm making my HANA table look like any other traditional database table. By default, if you did not do anything, it will always make your table as a column format table. If you look at the HANA database, typically system administration table, where every record has some configuration details, that is what will be typically a row format table. When in doubt, always create your table. Let the system create your table as a column format. Even if you're going to be reading detailed information from that table, you will not see any significant difference from a row format to a column format. Column format by default is superior in nature when compared to your row format. This is the direct visible change that we see going from a row format to a column format. Is everybody following me so far? By a quick show of yes or no. We can see that just by going into a column format, I am seeing a significant benefit in faster response time. Now, Virender has a question. Does it impact joining if one table is row and other is column table? It will, but again, it is not visible to a layman eye. It is so insignificant that you're essentially joining a summarized information on the column table to a detailed table, right? So it won't be humongous difference. You won't see it as significant when you're working on it. Define default. Oh, absolutely, Mike. So what I'm saying is, when you go into the system, in the coming sessions, when we go look at the system and create tables, when you say, I want to create a new table in the system, in HANA, it will ask you for a choice. There will be a drop-down button, which will say, do you want to create this table as a row format table or a column format table? If you forgot to choose this option, it will by default always choose column table for you, because HANA is built to handle column storage capability. So by default, it will always go and choose the column format, knowing that even if that table was to be bombarded with detailed question, a column format table can still handle that. Though there might be a very, very, very small difference in the processing speed, it won't be as significant as you would imagine. Like if you had asked that row, if that table was stored as row format and you asked a detailed question, it won't come back in 1 second. And the same question was asked to a table which is now column format, it wouldn't come back in 50 seconds. You won't see that kind of difference using a column format. If that was 2 seconds, this probably would have been like 2.5 seconds, something like that. So if in doubt, always choose, when creating a table, just choose blindly to create it as a column storage table. All right. There are a couple of other questions. Fred has a question. Will there be any need to store in the row format at all? If you know for a fact, there is a table which you will always only ask it for detailed question. There is no way you can summarize information. Let's say, for example, I have a student table. I have a student name, a student ID, student age. Let's not even, let's say student ID, student phone number, and address. Let's assume that I have a table which has, there is no um, amount or measure, no measure is available in this table. Okay, hope you are able to understand the process, Fred. I have a table which only contains master data information, which means that there is nothing to calculate out of this table. I have student name A, student B, student C. ID number is 101, 201, 301, 123, 456, 789, and I have address. In this particular table, tell me, Fred, is there any need for me to do summarization? If I summarize the information in this table, there is nothing for me to calculate, right? Exactly. No data that needs to be calculated. So I always know for a fact that this particular table, if I'm going to use it for any reporting, I am going to be needing detailed information. I'm always going to be needing detailed information. So if you were to choose, if you were asked by somebody to say that you have to create some tables as row format, otherwise I'm not going to let you go, then you would choose such tables where there is no possibility for summarization and make them as row table. But even in this case, what I would say is, if you're not sure whether it should be a row table or column table, by creating this as a column table will not degrade your performance. Though this table was not built for capturing column level information, summarized information, if you had created it by accident as column table, nothing will go wrong. Does that make sense, Fred? Hope it answered your question. So this could be a master type of data where there is no calculation needed, is a good example for where you can use row storage. All right, there's a question from Felix. Do you have situation where you would extract data from multiple tables? Absolutely. Yeah, when we go into data provisioning concepts, Felix, we will explain as to join information from multiple tables, right? You will have to bring information from different tables. Absolutely. Mike has a question. Where would I choose row format? Yeah, when I go into the HANA system, Mike, in the subsequent sessions, I will show you how to create a table. And when I create a table, I will show you how to choose that option. I will explain it step by step. And the even more cool feature in HANA is, let's assume that you went ahead and created a table. Let's assume the student table, you created it as column table, not knowing that there is an option for you to create it as column or store. You chose the default route and you went ahead and created a column table. You have loaded millions and millions of records into this table. And then you realize that, oh, this seems like a table which doesn't have any calculatable fields. I made a mistake of creating it as a column. I would really love if it was a row table. Even after having loaded the table into this column storage table, there are capabilities to convert this table from row to column and vice versa anytime. I will also show you how to, if you think that you have made a mistake and you want to switch it over, you can absolutely do it. And I will also, when I create the table, I will show you how you would convert a table from a row column to a column table, or to a column from column to row, vice versa. This shouldn't be an issue. Okay. Kofi has a question. Is there a risk in doing that, as you may be asked to update the table later to add more columns? Now, again, if you were to adjust the table structure to add or delete columns, it would still function the same way. There won't be any negative performance issue when you're doing it, because the internal algorithm, which is proprietary and that has not been shared, will be able to handle that adjustment of table structure. Vijayata has a question. Can we switch column table to row table? Perfect. I think I just answered that, Vijayata. There's a question from John. From what you're saying, it looks like column table is ideal for retrieving data. Do you also determine whether to use row or column for pushing data to? So the system internally, once you have defined a table, John, once you have defined it to be a column table or a row table, How HANA processes the data inside the table is going to be determined by the choice you make. If you chose the table to be created as a column table, it will behave in its default function. It knows, it's like fish swimming in water, right? It knows exactly how to process that data, sending into the column table. If you send the data into the table defined as row table, the Trex engine will not activate. If you remember, there is that second technology, the Pstartime technology. If you remember that discussion we had, that brings that right capability of a traditional database. So that will activate and say, I'm going to take over and send this data into a row table format. Does that make sense, John? That's how the system is going to differentiate. Okay, so that's why you don't want to confuse the system by making Trex get activated sometimes and Pstartime get activated sometimes. If you by default set it up as a column table, the maximum efficiency is brought by the Trex engine capability. Kofi has a question: with the speed capabilities of HANA, considering Pstartime, why emphasis on column over row? Is because the retrieval, right? It becomes critical when I'm running a report. Maybe 10 years ago, Kofi, it was okay for a report to run over the night and make the report ready for the user next day morning. It was okay for the user to wait for hours together to run a report. Now, if you go to any organization and you tell the report user to run a report, and if it takes more than, let's say, a couple of seconds, they are not going to be happy about it. They want data instantaneously. Now, the data retrieval, if it has to be instantaneous, what would you choose, Kofi? Given the choice of a row format and a column format, which would you use to retrieve the data? In this case, it makes sense to go for the column approach, correct? Because it can, I have to retrieve the information faster. That's why I will choose always the column storage. All right. Sure, Virender, I understand. No worries. I'll see you in the next session. John has a follow-up question. Would you have to adjust the schema or index at any point in time? Perfect. I think you beautifully gave me the segue to the next topic that I need to discuss. I'm going to be talking about indexing and partitioning concepts right now. Mike has a question. This is for data retrieval. Yes. So to retrieve the data from the table in the HANA table, if the data was stored in a column format, the retrieval becomes exponentially faster when compared to your traditional row storage format. But explaining the concept of row storage and column storage does not just stop at data reading or retrieval, right? Would everybody agree? So now we understand that by explaining the concept, we just understood column storage gives me the data reading capability. The data retrieval capability is significantly superior by going into a column storage capability. Would everybody agree at this point? By a quick show of yes or no, please. We have understood that by keeping the data in a column storage, which is not usual in a traditional database, which is only possible in this HANA database, I am making data reading extremely faster, which means that I'm making my reporting much faster. But there are some underlying hidden advantage by going into this column storage. Let's take that same table. Bear with me, I have to write it again. I'll quickly write it. Country, product, and amount, just to explain the concept, subsequent concepts. I'll say 2021, US, product A, B, 100, 200. Let's assume that I have this data. In addition to this data reading, there are other things that happens in a row system versus a column system. In a traditional database, what happens is, in a traditional row storage, system like SQL Server or Oracle, what's going to happen is this table can contain millions and millions of records. Would everybody agree? This can be ever growing table. A traditional row storage, if I send a query to this, if I ask a question to this particular table, by now you understand that if the data is stored in a row storage format, let's assume that there are millions of records in this particular table. And the question I'm asking is having the answer stored in, let's say, 999,998 record. Just short of my million records. Here is where my data is stored. The answer for my question is stored in this almost very last record of this table. A row format, to fetch this information, what is it going to do? It will continue to read the entire record by record by record by record all the way until it goes to the almost the millionth record. It's saying itself is too difficult for me to say that number. So I'm going to just say almost a 1 million record, right? Can you see that the time taken to fetch that information from your table, it has to scan your full table. The concept of a traditional row storage table to retrieve a result for a query goes through a full table scan. Imagine if it took 10 seconds for this traditional database to fetch this almost 1 millionth record. Imagine if this table was 10 billion records. And your result were somewhere stored in the 900 million section. How much time is it going to take? It probably is going to take multiple hours to fetch through this, because always a traditional database will go through a full table scan. It will go record by record because that's how the memory is stored. That's how the information is stored in the memory. So it will go record by record all the way through until it finds the answer. It will have to scan the entire table. Tell me, is this a sustainable process even for a traditional row-based database, RDBMS system? If I allow the system to always do a full table scan, it's not going to happen, right? So what we do in the database world is, I'll give you an analogy. I ask you to find a word called XYZ from your book. You have a book in your hand and you have to figure out, I ask you information about a particular thing in your book. You can do one thing. You can start from the first page, scan through the entire page, go on to the second page until, let's say, if it's a 300-page book, the information is in the 250th page. You would have scanned through 249 pages until you get to the answer, which is on the 250th page. Is that approach correct? Or would you look at the table of contents and identify where this information would be and jump directly to that section and find out the answer? Which approach would you take? Is the choice of table of contents and jumping to the section better performance, or scanning the entire book is better performance? The analogy of scanning the entire book is like your full table scan, and using a table of contents and identifying where you have to find this information and jumping directly there is a better performance, right? So taking that same analogy, database has this concept. In order to accommodate ever-growing needs of a table will always be supported with a concept called as indexing or index. So what will happen is, for a table, you will, as a developer, will have to go and create another object called as index. What this index will do is, it will have a pointer. Let's say in this particular table, I am going to have pointers on my year and my country field. Then what I'm saying is, I will say year, I have index 1, which is going to be based on the column year. It will say 2021 value, and it will have a pointer field. It will say it's available in row 1, 2, 3, 200, 500, 700, 900, and so on and so forth. It will keep a track of 2020, and 2020 will say it's in column row 4, 7, 9, 11, 15, 21, 2000, and so on and so forth. Now imagine that it is just like your table of contents. A report needs to be run, and the report is asking, I want information about year 2020. I want all information about 2020. If I took the traditional approach of full table scan, it has to go through the entire 1 million record, identify wherever 2020 data is entered, and it has to fetch that information. Rather, if you had an index maintained on top of this table, it will go here. It will say, okay, now it knows these are the list of records where 2020 is available. So using this, it will go to this table and fetch only that particular table. So the indexing on top of this table is helping me reduce my table scan timeline. Does that make sense? A quick show of yes or no, please. Indexing, just like your table of contents, is going to help me process the information a little more faster. But in a traditional database like SQL Server or Oracle, indexing is not going to happen magically. It's not an automatic event that happens. You as the developer have to create it, and you have to go and maintain it every day. Today, the 4th record and 7th record had 2020, and somebody went and inserted a new record in the 5th position for 2020. I have to go update my index pointer. Right now, I have to say 5 is also containing the 2020 record. There is a lot of maintenance that needs to happen. Is everybody understanding what we are heading? In a traditional row storage system like SQL Server and Oracle, you have to do this additional indexing work on top of maintaining your table. On the contrary, because column storage in HANA treats individual columns as objects of itself. I have country, I have product. This is how the information is stored in the column storage, right? Every column is individual on its own. I have 2021, I have 2020. I have country US, I have country India. I have product A, product B, product C, 100, 200, and 50. Every column automatically behaves as an index by itself. You don't need to do anything special. So what you would have traditionally done in a SQL Server or Oracle is you would have had to do the manual step of creating an index and maintaining it. But in a HANA system where the system itself is maintaining the data as column by column, each column behaves as an index on its own. You don't need to create any indexes separately. Does that make sense? So that again is an unknown hidden advantage that you're getting, right? In addition to doing the data reading, now there is no need for index. You're not spending additional time maintaining and creating an index on top of a HANA column table. Just like that, in a traditional system, again, if the data volume goes significantly larger, you will partition the table. You will say that I'm going to store all my 2021 data in one table and then 2020 data in another table and so on and so forth. So in order to separate the data into multiple tables, you have to go through a partitioning concept, which is again a maintenance activity. You have to go as a developer, identify on what column am I going to partition the table and how many partitions do I need. And you have to constantly keep maintaining it. Again, in your SAP HANA, because your data is separated by individual columns, they are automatically partitioned. The system automatically, when it hits a 2 billion record, when a table in HANA, which is columnar in nature, hits a threshold of 2 billion records, until then it doesn't need to do any kind of partitioning, because the table volume itself, the individual columns itself are indexed and partitioned automatically. You don't have to do anything. But the system also has an overwriting threshold which says, for no matter if your table crosses the threshold of 2 billion records, it will individually automatically go and create a partition and maintain it on your behalf. You don't have to do anything for maintaining that. So the advantages you're getting just by moving into a column storage is no indexing, no partitioning, and of course your main concern is extreme high reporting performance. Now, the final hidden advantage you get by going into this column table is, so I'll just quickly recap here, advantages of column storage. Read performance, no indexing, no partitioning. Is everybody with me so far? There are a couple of questions. Let me quickly read them. John has a question. Does it mean the column table already has a built-in? Yes, it has a, because it treats each column. If I were to put it in a very simpler terms, right, John? Think of a column table takes each column in your HANA table as individual tables. It will treat each column as an individual table, and it has inbuilt indexing capability on each of those columns. So we don't have to do anything about indexing or partitioning with a table which is created in HANA. Mike has a question. Why would you need to partition a column? You don't need to. So the concept of partitioning will not be pertinent to a column. It will, what it is thinking is, even when the data is stored, let's say, for example, each column in a table will have a lot of repetition value. Would you agree, Mike? In the case of the column called year, 2021 can repeat in several million records, 2020 can repeat several. But how the data is stored inside the table? It only stores the unique values within that column. Would you agree? So as you asked, it's a valid question. In this case, that column is not going to potentially have large volumes of information. If I'm going to store 5 years worth of data in this table, I will have 5 entries in this field, in this column called as year. But the reason why at a 2 billion record threshold, it automatically goes and creates a partition is, there could be some columns in your table. I can have an ID column or an invoice ID column. You will see that invariably all the values are unique. An invoice ID number will not repeat in every record, right? That possibly can have 2 billion individual entries, unique entries sitting inside that particular column. So what happens is, if you let a columnar table with an individual column having too many unique entries, you are starting to hit the degradation capability of the underlying proprietary algorithm. So they don't want to compromise the performance of the internal algorithm. So what they will do is, if assuming that you have a column in your table that can potentially have so many unique entries that can try to degrade the performance, they, out of abundance of caution, they will go ahead and create a partition on the table automatically. That's all it does. Hope it explains the question, Mike. That is where the concept of partitioning would come into play for a HANA column table. Is 2B fixed? Oh, yeah. Is the 2 billion fixed? Yes. You can, on top of it, you can be, you can say that I don't agree with HANA's concept. I want to do it at 1 billion itself. You can override that, The default nature is 2 billion. If you did nothing about a table, which is what you would normally do, automatically when it hits the 2 billion threshold, it will go ahead and partition the data. Okay. So now we have seen that these three advantages are there. I will explain. There is one more unknown hidden advantage for storing your data in a HANA system with column storage than a traditional row storage database. If I have, let's say, 10 million records in a table, and it's a large table, let's say there is column 1, column 2, column 3, and assume there is like 10 columns in this table, and I have a 10 million records stored in this particular table. When this data is stored in a row storage traditional database, can anybody guess and tell me how much space am I going to occupy in my, if I were to, so this is my SQL Server database, let's assume, sorry. This is my SQL Server database. I have this 10 million record table with 10 columns. I have to store this data. Would it be fair to say that it could be like a 50 GB table? If I were to throw a number. Because I am storing every row's data in contiguous memory. So I can potentially occupy, let's say, 50 gigabytes of information. If the same table was stored in a HANA column storage table, where the system, how it does, it will take each column separately and it will only store unique entries into these columns. If 2021 repeats 5 million times and 2020 repeats 5 million times in this table, the value of 2020 and 2021 will be stored in your database 10 million times. But in your HANA storage, it would be stored 2 times. So can anybody think of what's happening by going from row storage to column storage for a space perspective, from a space perspective? Would you agree that HANA will tend to store less amount of data for the same table? Exactly, right? So storage is compressed. Would everybody agree? If it took 50 GB to store this data in a traditional database, the same data, when it is stored in a columnar table, it will probably end up being like a 2 GB space, because it is removing any redundant information from the table storage. Does that make sense? So that is another compression plays another significant advantage when you store your data in the HANA column storage format. So the capability of read performance, the capability of not needing to have an index, the capability of not needing to maintain a partition, and the advantage of inherent compression. These are all the advantages that is brought over by your Trex engine. So Trex engine's row versus column difference. If I am just talking, if you remember when I started this discussion about Trex engine, if I could go back a little bit quickly. Let me just quickly go back here. If you remember, I said when talking about Trex engine, there are 3 major things that we need to talk about. Just talking about row storage versus column storage, we found that the read performance is improved, no index, no partition, and added compression. Is everybody clear so far? By a quick show of yes or no, please. It's critical for you to know this information because now you are now knowing the details behind what is happening with the Trex engine. In tomorrow's session, we will talk about what is this massive parallel processing, what is this push down mechanism. And then by knowing these things, you know exactly how in-memory computing is superior to its traditional counterparts. All right. So I think that this is a good stopping point for us because I've given you a lot of information. Please try to recap all this information before our tomorrow's session so that you will have a better understanding when we go into the next topic of massive parallel processing and what is push down mechanism. By knowing these three concepts, what row versus column storage means, what kind of advantage it's bringing, what massive parallel processing is bringing to HANA's plate, and what push down mechanism is doing. If you understand these three concepts, then you know how that technology is working. Now you understand what are the three technologies that comes together to make your SAP HANA system, your Trex Engine, your Pstartime, and your MaxDB. Now we are getting into this question of how. By knowing these three concepts of row storage versus column storage, massive parallel processing, and push down mechanism, you will have a complete good understanding of why SAP HANA database in memory is powerful than your other capabilities or other traditional databases. So Fred is saying, oh, thanks, appreciate it. He's saying that you are a fantastic teacher. I appreciate that. Thank you. Can you help devise what's the best way to study for this program? Absolutely. So everybody who has joined this training, you will be soon given access to a learning management system, LMS system, a portal. So what I typically do is all the writings that I'm doing, the things that I have written down here, I will post this OneNote to the learning management system. So you will have a copy of this notepad. And what I would recommend is to keep it fresh. Anytime I'm explaining it, maybe before the class tomorrow, what you can do is you can just, it will take you maybe 2 minutes, because the moment you see a visualization, whatever I spoke should hopefully come back to your memory saying that, okay, this is what this diagram means. So in about 2 to 3 minutes, you should be able to quickly go through this information. And that is one of the things that, but these are all theoretical concepts, right, Fred? From maybe next session, we will wrap up this information. But in the subsequent sessions, we will go into the system and start doing hands-on. All right. So hopefully the information that we presented today was beneficial for everyone. We will talk tomorrow. Perfect. All right. Sounds good. Thanks, everyone.
Thank you for attending the session. I hope you all enjoyed it. Don't forget to visit our Vimeo page and follow for more upcoming videos.